What is the advantage of this one? Because of replication we are maintaining on our machines, in case of any of this machine is down, for example, see this machine is down, the first machine is down, then automatically as we have a backup of this and this here, we no need to worry about it. That means Hadoop want to provide high availability data. As Hadoop want to provide high availability, in case of any of the machine is down, okay, then we should not be in trouble. We should not lose any single bit of data also. Even though high fault tolerance occurred, means even though machines are down due to network issue or software issue, all that should be achieved by using a concept called replication. Okay, when we are discussing about our HDFS, we will discuss how to create a replication. In case if any developer want to change the replication factor, how he can change, what is the way data flow is going to happen, how heartbeats will be communicated. Heartbeat means a communication between your data node machine to name node machine. See, this is down, right? This then how our name node machine, master machine know this is down. Actually, this machine should send every 3 seconds one message back to this name node. That's called heartbeat. If heartbeat is not receiving to this name node machine, then name node feels that that particular data node machine was failure. The issue may be anything, network issue, software issue, hardware issue, anything. But if heartbeats are not receiving back to name node, then name node feels that that particular machine was down. Like this, okay, we are going to discuss entire Hadoop archives, HDFS, web UI, Hadoop commands and live environment. Let me just, I already log into this Hadoop environment, and if you want to go for the command line of this HDFS, you can just click on the top corner command line. This is a command line. Click on this. When I click on this, it is going to open a command line environment here. In this one, we can type a command sudo, the basic command, space JPS. When I type this sudo JPS, it will going to display the what are the services are running right now. Okay, they're in the background. Task tracker, job tracker, name node, data node, secondary name node, okay, run jar, application server, they are all right now running. If you want to change any other service also, you can change by logging to Cloudera Manager. And here, this is the place where you are going to execute your commands. There are multiple commands you can execute. So what are the commands you want to execute? Here you are going to execute, because this Hadoop, when you are storing the data in distributed systems, all these distributed systems are going to have the data in distributed fashion. To store the data in distributed fashion, we are going to have some commands are there. Let me just show you what kind of commands we are going to have. Hadoop space DFS space hyphen help. See, when I just type the command Hadoop, space DFS space hyphen help here, it shows the list of possible commands in this mission. See, list of possible commands which we can execute. The command which I typed here is Hadoop space DFS. What is the meaning of DFS? Means distributed file system. And hyphen help means what are the basic commands we are having. What kind of commands we can execute in the command line means cat command, chgroup, chmod, chown, copy from local, copy to local, count, cp, disk uses, get, mkdir, expunge, touch, test, okay, rmd, rmk, help, ls. These are the different kind of commands we have in Hadoop. These commands we can use to move a file, to copy a file, to delete a file, to create a directory, to get a file, to display only some part of content, to create an empty file. These are all different kind of commands we are having. These all commands also we are going to discuss as part of our Hadoop HDFS discussion, that is Hadoop commands and hands-on live also I will explain. And HDFS web UI. See, instead of every time opening this command line, executing the command, seeing the result, we also have web UI is also available. This is the web UI environment. When I click on this browser, I'm able to see some web UI. Here if you want to log into the name node mission, you can click on name node mission. It shows you when this name node mission was started, what are the files already there, browse for the files, user, see Cloudera. These are all the files I stored. See, it shows here what is the name of the file, okay, what is the size of the file, replication factor 3, 120, block size 120 MB, when it is created, permissions, who is the owner, who is the group. So all the kind of information we can see. For example, if you want to open the data of any of this file, also click on here. You can see the data of that particular file is also. That may be audio file, video file, text file, any file you can store on HDFS. This is all we are going to discuss. Once we store the data in distributed fashion, we also start doing the computations across the cluster. To do these computations, we are going to write some kind of algorithms. Those are generally going to write in a programming language, either Java or .NET or Python. That algorithm we simply going to call as a MapReduce. In Hadoop, once data is distributed across the cluster, if you want to do calculations in, computations across the cluster, we are going to write some algorithms. Those algorithms we are simply going to call as the MapReduce algorithms. I'll show you how to write the MapReduce programs. Okay, before we are going for this one, I'll provide you some core Java materials, okay, because here are core Java recording sessions actually. We should know about Java also. Little bit of Java, what is a class, what is object, what is a method, what is OOPS concept, what is inheritance, polymorphism, and how to create a program in Eclipse, how to call that program into Hadoop environment. Okay, these all actually we need a Java part. Instead of again separately discussing Java by me, we are providing the previous class recordings of Java. Those will be useful to understand the Java part and practice the Java part, also writing the simple Java programs. Then before we go into this MapReduce, you can just go through the Java recordings. Then you will have a clear idea of what is Java and everything. Then once we are in MapReduce, we start writing the MapReduce programs. Let me show you a simple program how we are going to have this MapReduce programs. See, this is the one MapReduce program. These kind of the Java programs we are going to write in the MapReduce. We are going to import list of APIs, and we are going to create a package, and we are going to have a multiple classes we are going to write. In the MapReduce programs, we generally going to have map method as well as reducer method. We simply going to have map and reducer, and void main method also we are going to have. Means simply speaking that in the MapReduce programs, map and reducer are two methods, and driver is a one method which is going to control the execution of this entire program, and even map and reduce also will be controlled by that particular one. Okay, we need to write this kind of programs in Eclipse. Once we write this this kind of programs in Eclipse, we are going to create a jar file. That jar file we are going to call into our Hadoop environment, means from command line. See, as command line we are going to run the jar file. But if you want to run the Hadoop jar file, first you need to create the jar file in Eclipse. See, the place where we are going to write our programs is nothing but Eclipse. Eclipse is on IDE, Integrated Development Environment, the place where we are going to write our programs. We will discuss, okay, multiple programs, how to write the program, how to call that program into our HDFS environment, how it will going to interact with that systems. So this is the place where we are going to write the program. I'll show you in actual class, okay, how to write the programs, how we are going to have a classes. See, this is the one, public static void main class, and this is a mapper class, mapper method, this is a reducer class. They all I will show you in actual class how to write. Before that, we will share you the recordings of Java. You can just go to the recordings. Don't worry about this one. You can easily understand, because to write these programs at least we need core Java part. This okay? Core Java you can learn parallelly, and you can easily understand this MapReduce programming. And we will also discuss about what is the difference between the MapReduce version 1 to the MapReduce version 2, that is MRV2, that we simply going to call it ARM. Those we are going to discuss. Once we are done with that, we'll go for a pig. What is this pig? See, MapReduce is a platform where we are going to write some kind of algorithms or programs. These algorithms are the programs which we are writing there in the MapReduce. We are going to have programming, right? Who are from the non-programming or non-Java background, they don't want to write the programs every time. They want to write some scripts to do the same operation. There is a separate ecosystem component is available for that. That is pig. Pig is one of the ecosystem component which can use it to write the same kind of MapReduce programs in the pig. But we are not writing a coding there. We are writing a script there. That script is going to execute on top of Hadoop to fetch the data, to generate the analytics, and to create the bags in pig. That is, pig can run in two modes. One we simply go to call as local mode of our pig, and MapReduce mode or distributed mode also. Okay. In actual sessions, I'll show you how to go for the pig and how to see. If you want to enter the pig, just you can type the command called pig. When you type the command pig here in our command line, now you are into the shell. This is called grunt shell actually. Right now you are in pig grunt shell only. As you are in pig grunt shell, here you can execute the pig commands also. Pig is going to create a tables in the format of called bags. Okay, what are the bags we are creating? If you want to display the bags, you can display, and you can create a bag. While creating a bag also, we are going to follow some syntaxes, group by class, having class. So all are we can achieve with using of our pig. But advantage when we compare with the pig and MapReduce is, whatever the program you are writing in 200 to 300 lines of MapReduce code in Java, the same you can run in pig with 10 to 15 lines of code. It's a very user-friendly environment with comparison of MapReduce. And one more is, it's also very simple with comparison of the MapReduce, because MapReduce is a platform you are going to write a programming. And this pig was developed by Yahoo. This is also one of the ecosystem component right now under the top level license of Apache. Most of our companies nowadays are also using pig instead of MapReduce. If you don't want to go for MapReduce, yes, you can go for the pig directly to do all our operations, whatever we are doing in this one. But MapReduce is better to go for unstructured data. Pig is very, very good for structured data processing. For doing of this one, how to write a pig. And in the pig, I'm telling that you are going to have some scripts. Those we simply going to call as a pig Latin scripts. To write those pig Latin scripts, we are going to use a language called pig Latin. It look like our Unix scripts or SQL queries. Okay, we will discuss that one, how to write and what is the schemas, what is the data types and everything. Then we are going to have one more component called Hive. If you see in this ecosystem, you can understand. On top of HDFS, we are going to have MapReduce. On top of it, we are going to have pig, and we are also going to have Hive. What is this Hive? What is the purpose of this Hive? In our Hadoop ecosystem, we are going to have a concept called, just a minute, Hive. Hive is going to work as a data warehouse within a Hadoop. Mean a data warehouse infrastructure built on top of the Hadoop for providing data summarization and query analysis, for ETL tools, for structures, for querying, accessing of different storage devices and everything, that we are going to call as a Hive. Hive is going to follow a similar kind of SQL language that's called HiveQL. It's also having some functions, data types, formats, scripts, and Like our databases, we can also improve the performance by tuning the queries what we have in Hive. And when you go for the Hive, when we compare with the normal SQL database to Hive, what it is going to support and what it is not going to support in Hive. Especially by using Hive, we are going to create some tables. Those tables are the input for the analytics part. That means summarized data we are going to maintain up the tables what we are creating in Hive. Those summarized data will be used by analytics team to generate the analytics for the business. And Hive can directly interact with the HDFS to get the data. Hive can also directly interact with the pig. Hive can also directly interact with the HBase also to get the data and to create the summarized tables. How it is going to interact means it's going to write some SQL queries. Those SQL queries we simply going to call with the name called Hive killer. Okay, I'll show you how to work on Hive and what kind of the documents we are going to use when you're writing SQL queries, how it is going to have a flow. See, even though you are writing a Hive query, that query will, see, you are writing a simple select query here, something in Hive. That query will be going to the system. It will going to create some MapReduce program, and that MapReduce program will execute on top of the HDFS and get the data back to you. This is the way Hive is going to execute. In background of Hive also it is going to have a Java programs, MapReduce programs only, but we are going to write a simple SQL code instead of writing a biggest program in Java. That we are going to discuss how to work on Hive, how Hive is going to create summarized tables and everything. After every unit completed, you are going to have some assignments as well as every session recording also you will get. Then we will go for a HBase. What is this HBase? In a Hadoop ecosystem, we have a one NoSQL database is available. That means this is a one database, but it does not follow any SQL. That NoSQL database we simply going to call with the name HBase. This HBase, whatever we are having, okay, this HBase, whatever here, that HBase is the one where we are going to maintain that NoSQL database, as well as this HBase does not follow any SQL queries. It does not follow any SQL to read the data from HBase, to load the data into HBase. You are going to write some small commands, put command, get command, scan command. These kind of very basic commands are going to be used by HBase to retrieve the data, to load the data, huge petabytes of data. Assume that in a project we have a warehouse, data warehouse data. That data we want to extract and we want to store in Hadoop ecosystem. That data directly we can extract and we can directly store it to the HBase. HBase is the one which is going to follow the similar kind of table structure what we have in our thing, but HBase is not a rows and column structure database. It will not follow. It will follow column family structure. We're going to have multiple columns followed by column family ID that we are going to have in HBase. Right, that's also okay, how to create a NoSQL database, how to insert the data. So all we are going to discuss in our HBase. How we are going to have this one and how we will specify all the things. Once we are done with the HBase, then we'll go for the scoop. Parallel we'll also discuss about the scoop. Scoop is a kind of ETL tool actually. What is this scoop means? Scoop is also one of the ecosystem component in Hadoop, which is going to have a two mechanism. One is called import and export. Let me show you ecosystem diagram. See here. See, this is the scoop. It has the flexibility of importing and exporting of the data. From where it will going to import and export the data? Scoop will import and export the data from existing RDBMS systems. For example, we have RDBMS systems like Teradata, DB2, Oracle, like this. When we have these kind of RDBMS systems, if you want to read the data from those kind of RDBMS systems into Hadoop, we are going to use a technology called Scoop. Again, what are the data we have in HBase here, or what are the data we have in Hive or HDFS? If you want to send back the data to RDBMS system from Hadoop to RDBMS systems also, we can use Scoop. Scoop is a technology which is we are going to use to do both vice versa, reading the data from Hadoop and loading the data into Hadoop also. Okay, both importing and exporting operation if you want to perform, we use Scoop. But Scoop is only useful for structured data. Please remember that it's not useful for the unstructured data processing. It's going to be useful for only structured data processing. But how to get the unstructured data into Hadoop environment? There is a separate ecosystem component called Flume. By using Flume, we can interact with the weblogs, and we can also interact with the social media sites, audio files, video files, and get those files data and store into HDFS or any other environment. Means Scoop is for structured data and Flume is for unstructured data. And what is this H catalog? H catalog is just a metadata management system. It does not maintain any separate data or something. This is the one which is going to create some metadata for the tables. What tables? Means the tables whatever we are creating in Hive for generating of data, the data will be useful for analytics part of Hadoop. That table related schemas are going to be maintained in separate system called H catalog. That also we are going to discuss how to do that one. And next, once Scoop and Flume is done, we'll go for Oozy. See, Oozy is a one which is going to use one of the ecosystem components. See here, Oozy. This Oozy will do a kind of scheduling. See, for example, we have each and every ecosystem component, right? This ecosystem component will need to schedule. First, Scoop need to extract the data from existing RDBMS system to HDFS. Then HDFS to MapReduce. Then the data will be used by HBase or Hive. Like this, we need to do schedule, which need to be run first and which need to be run last. To do such a kind of scheduling, we are also going to have a one ecosystem component called Oozy. We'll also discuss about Oozy, and we'll go for the how other ETL tools are going to connect with the Hadoop ecosystem. See, some companies what they are doing is whatever the existing data warehouse system they have, that data warehouse system's data they want to move into our HDFS. Then at that point of time, we should know how to connect from the Hadoop to ETL tools like Informatica, DataStage, MSBI. In MSBI also we have SAS, SIS, Pentaho BI. These all are different ETL tools actually. What are the, just now I spelled the names. Those ETL tools, how to connect from Hadoop, how to work, and how to set up the configuration, and little bit about the administration part also we are going to discuss how to set up the cluster configuration and administration and maintenance in admin part, because we also should know basic things about admin. Then we'll go for one project. Finally, we'll be ending with the one of the project.